Salam and welcome everyone to my channel. Today we're going to be working on the physical chemistry question that says a perfect gas undergoes isothermal compression, which reduces its volume by 1.8 dm cubed. So from the first sentence, we know that it is an isothermal compression, meaning the change in temperature is zero because isothermal means constant temperature, and compression means a reduction in volume. So the volume is going to decrease, right? So, meaning the volume at the beginning is greater than the volume at the end. So, the initial volume is greater than the final volume. So, and it reduces its volume by 1.8 dm cubed, meaning the change in volume is 1.80 dm cubed or liters. Dm cube and liters mean the same thing. The final pressure and volume of the gas is the final pressure and volume of the gas are 1.97 bar. So final pressure, which is PF, is going to be 1.97 bar. Let's just stick to writing this as dm cubed since we have another volume saying dm cubed. But just know that dm cube and liters are literally the same thing. I believe dm cube is used in the UK and liters is used in the US. So final pressure is 1.97 bar, and the final volume is 2.14 dm cubed. If you remember correctly, I mentioned that the initial volume is greater than the final volume, and then we have the change in volume to be 1.8. So that just means that our initial volume, we can solve for it here, is going to mean the final volume plus the change in volume. And our initial volume is going to be final volume 2.14 dm cubed plus 1.8 dm cubed to get 3.94 dm cubed. You can see how the initial volume is greater than the final volume. That's to tell you that it's really a compression. So calculate the original pressure of the gas. So we're supposed to solve for initial in bar. So that's the first question. And then in torr. So what we're just supposed to do is to remember that since this is an isothermal reaction, or isothermal compression, and we know the change in temperature is the same. Sorry, the change in temperature is zero, meaning the temperature is the same all throughout the entire reaction or compression process. It's important for you to know that we would use the formula P initial times V initial equals P final times V final. You know, not regularly we have PV equals nRT, right? The temperature in this case is going to be the same. So even if you put it and do PV equals nRT for one and then PV equals nRT for two, it wouldn't make any sense because the temperature is the same. So it's going to just simply cancel out if there was a P initial, V initial, N initial, and T initial. So the temperature will cancel out because the T initial and the V initial is basically the same thing. The number of moles will cancel out because they did not tell us the number of moles increased or decreased, or there was a hole in the container where the number of moles removed. The constant is always going to be the constant. So the number of moles, the gas constant, the temperature, all are going to be the same. So you can simply remove them from the equation. So you'll be left with P initial, V initial equals P final, V final, which is what we have here. I'm just teaching you how we got to this point. This is like the quick method. If you want a better understanding of it, then you should go back to your textbooks and read about this particular, or you read about combined gas law. It's going to teach you how to work with P initial, V initial is equals to P final, V final, and how you get to those points. I've just given you like a short summary. So we have our P initial to be, we don't know, that's what we're solving for, so we're going to just simply have P final times V final over V initial. So that's going to be P final, we know that to be 1.97 bar, times V final to be 2.14 dm cubed, and our V initial to be 3.94 dm cubed. We can go on to cancel out the units and then input all of this information in the calculator, where P initial is going to be 1.97 times 2.14 divided by 3.94, and then you have a bar right here. So you input this information in the calculator to get 1.07 bar. So that is it. So that's the P initial. That's what you get for the P initial. Now we're asked to solve it in terms of torr. Now it's important for you to know something, that 1 atm, because anytime you're given a unit conversion question, you have to either memorize it or you have to memorize how everything is in relation to atmospheres, which is what I do. So one atmosphere is the same thing as 1.01325 bar, and then one atmosphere is also equal to 760 torr, which torr and mmHg are basically the same thing. So this is just teaching you that one atmosphere, oof, I don't know what's, yeah, this is just teaching you that one atmosphere, since it's equal to both, so that means 1.01325 bar is the same thing as 760 torr. So you just use the knowledge of comparison of what you already know, which is one atmosphere. And I like to use one atmosphere because it's just one. It doesn't have like a big number in front of the unit. It's just one. So this is how you do it. So now I'm going to teach you, we're going to solve this we're going to solve this unit conversion without using dimensional analysis. We're going to use proportionality. So which means that 1.10325 bar equals 760 torr, but we are asked to solve for 1.07 bar. So that means 1.07 bar would give you what? Like, what is it going to give you? What is it going to give you? You don't know. That number that we don't know is an unknown. So we can denote it as X. And then we can just do simple math and just simply cross multiply. So that would just mean, rather than writing the entire thing through dimensional analysis, you can do this quick method. So that would just mean X, write your unknown, times 1.01325 bar equals 760 times 1.07 and then bar and torr. Like basically, I'm just separating the units from the information. So the X unknown is going to equal, first of all, before we go on to solve it, you can make your work easier by just simply canceling things out. You can cancel out bar, cancel out bar. Since we're going to solve it in torr anyway, so let's go up a little bit. We're going to end up with 760 times 1.07 torr divided by 1.01325. And when you solve this, X is going to equal, it's going to equal 802.566 torr. And in three significant figures, which is what we've been having the information so far, X, the unknown, is going to give us 803 torr. So to answer your question, finding the initial pressure in torr is simply 803 torr. And the initial pressure in bar is going to be 1.07 bar. So if we zoom out, you can see all of our work and you see that we've answered all the questions correctly. And this is basically our answer. We have first of all broken things down, solved for the initial pressure using the combined gas law. And when we found it in bar, we were now able to do unit conversion to find it and determine the initial pressure in torr. So if you have any questions, please write it down in the comment section. If you want personal tutoring as well as group tutoring, I tutor students from all over the world. So make sure you email shuhabitutoring@gmail.com and ask for me, Habiba, and I'm going to be able to help you with your schoolwork. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.